welcome to our YouTube channel. In this video, we are going to talk about how to write chemical formulas of any compound in chemistry. Now, when we want to write a chemical formula of any compound in chemistry, the first thing that we have to consider is a valence. A valence. Now, what is a valence? A valence is simply the number of electrons which can be gained, lost, or shared during a chemical reaction. Now, these valences can be obtained using elements on the periodic table. So we have elements from the periodic table. Apart from that, we also have what we call radicals. We have what we call radicals. So these two will help us to obtain the valency. Let us talk about the elements. An element is the simplest substance which cannot be broken into two or more simpler substances by any chemical means. These elements were already discovered by some people who discovered the periodic table, like Antoine Laurent Lavoisier. But we are not going to talk about that. Let us just talk about the elements on the periodic table themselves. Now, these elements on the periodic table, we will start from group 1 up to group 8. So, from group 1 to group 8. Now, this is what we are going to do, so that we know the valences of these elements. So I am going to divide this into two parts. So I'm going to put group 4 here. Then I'll put a line here. Now, this is what I want us to understand. For elements which are from group 1 up to group 3 and some in group 4, which means group 4 and below, these elements can only lose electrons. They can lose electrons. Then these which are above 4 up to 7 somewhere there, they can gain electron. So they gain electrons. Now, apart from that, most of those which are from the group 4 and below, they are metallic elements. So they are metals in short. Then these from 4 and above, most of them are non-metals. These are non-metals. Now, take note that for those which are less than 4, they lose electrons. For those which are above 4, up to 7, they gain electrons. Remember, we said a valence is the number of electrons which can be gained, lost, or shared during the chemical reaction. In this case, take note that those which are below group 4, always when they lose these electrons, they become positive. So they become positive. Then these which are above 4 up to 7, they become negative. Now, it is something which is confusing to some learners, whereby when when an atom or an element loses electrons, then it becomes positive. Because losing is more like you are reducing. Now, in reducing, we say to reduce is to subtract, but you find that the charge becomes positive. Now, why? Let me give an example of oxygen. If we go on the periodic table, we find that oxygen is an element which is written like this. Down here, we find 8. Up here, we find 16. Remember, this is the proton number. The proton number of any element is equal to the number of electrons that that element has, as long as that element is neutral or that atom is neutral. Therefore, we are going to get this 8 as equal to the number of electrons. Therefore, we are going to say, let's say we have 8 protons in oxygen. So 1, 2, 3, 4, 5, 6, 7, 8. Which means we have 8 electrons in oxygen. So we are going to pair them like this. Now, remember that oxygen is an element which is found on the periodic table in group 6, which means it has got 6 electrons in the outermost shell. Now, for it to be stable, remember we said those which are above group 4 to 7, they can only gain electrons. Which means if in the outermost shell of an oxygen atom, there are 6 electrons, how many can we add to make it 8 so that this oxygen atom becomes stable? Which means we are going to add 2 electrons. Now, let's assume that oxygen is gaining because we are adding, which means what is gaining is oxygen. Therefore, we are going to add 2 electrons. You can see that these 2 electrons are not pairing with any of the protons because the number of protons will just maintain as 8. But the number of electrons, since we have added 2, they become 10. Now, these 2 electrons can be written as -2, just like that. Now, this is the number of electrons which has been gained for oxygen to attain its what? Stability. Therefore, we consider this -2 as a valency of oxygen. Let's go to another example, which is a quick one. Magnesium. If we go to magnesium, we find that in magnesium, the outermost shell will consist of only 2 electrons. And it is also in group 2, which means for magnesium to be stable, it has to lose 2 electrons. Now, if it loses 2 electrons out of what it has, which means it is going to reduce the number of electrons, making the number of protons not be equal to the number of electrons. So there will be more protons than electrons. Now, to represent those protons, we are going to say there are 2 extra protons. That's why magnesium ion will have something like this. So this shows the number of electrons magnesium lost. But we know that these are free protons that we have in magnesium ion. So these are valences. Thank you so much. Let's jump to radicals. Now, what is a radical? Simple and straightforward. A radical is a group of elements which only exists in compounds. For example, we have hydroxide or hydroxyl. This group of elements will only exist in other compounds like sodium hydroxide, magnesium hydroxide, and so on. So this will just exist like that. Now let me give more examples of these radicals. Apart from hydroxide, we have carbonate. Apart from carbonate, we can put sulfate. Apart from sulfate, we can put phosphate, and so on. Now, look at the table that I have just displayed. You can see that we have those radicals which have valence 1, those which have valence 2. So on valence 2, we can count there are 1, 2, 3, 4, 5. Then in valence 3, we only have 1. Which means if we want to memorize these, we just memorize those in valence 2 and 3. Because in valence 2, there are just 5, as we can see. Then in valence 3, we only have 1. Therefore, it will be so easy for us to memorize those in valence 2 and 3. Then let's say a radical is not found either in valence 3 or valence 2, which means automatically it will be found in valence what? Valence 1. For example, I say nitrate. You can see that nitrate is neither in valence 2 or valence 3, which means automatically nitrate has a valence of what? -1. So let us take time and study this table that I have just displayed. We move on. Now, let's say we are given a word like magnesium hydroxide. Magnesium hydroxide. Now, they want us to write the chemical formula for magnesium hydroxide. The first thing that we are going to do is, let's check the group number in which this magnesium is found. Then we go to the radical hydroxide. Magnesium is found in group 2, which means it has a valence of 2. But remember that the group number of an element on the periodic table does not represent the valence. But what represents the valence is the number of electrons that element can gain, lose, or share during a chemical reaction. In this case, magnesium has 2 electrons in the outermost shell. Remember, we said those which are below group 4, they can lose electrons. Therefore, magnesium has a valence of 2 in the compound. So we'll say positive 2 because it will lose 2 electrons for it to be stable. Then we come to the hydroxide. The formula for hydroxide is OH. Then what valence does hydroxide is attaining? So when we checked on the table, we find that hydroxide has only valence 1. So we can put 1 there. Now from there, we want to write the chemical formula for magnesium hydroxide. What are we going to do? We will drop this magnesium. We will drop also this hydroxide. Then we are going to swap these valences. So this valence will come this side. So we'll put a 2 here. Now remember, hydroxide is OH. These 2 are together. So since they are together, this 2 applies to oxygen and also hydrogen. Now, for us to do that, we are going to introduce brackets. These open brackets. Then here we have 1. So we'll get this one and put it there. Now, 1 doesn't change anything in multiplication, which means we are going to just ignore it, but it is there. So we'll say the final formula for magnesium hydroxide will be Mg open bracket OH close bracket 2. So this is the formula for magnesium hydroxide. Now, for more examples, don't forget to hit the like button and subscribe to our channel for more videos on more chemical formulas that we are going to drop down. Thank you for watching.